Hi everybody, this is Module 4 for Math 025, Part 1 of Module 4 for Hartford Community College, Math 025. The first part of this module, we're going to start talking about complex fractions. And a complex fraction is a rational expression whose numerator or denominator contains one or more fractions. So it can be the numerator and the denominator, or the numerator or the denominator. And a complex fraction can be simplified so that it becomes a rational expression, which we dealt with in the last module. And just a reminder that a rational expression is the quotient of two polynomials. So to simplify a complex fraction, we're going to find the least common denominator of all the fractions in the complex fraction. We're going to multiply both the numerator and the denominator by the LCD. We will simplify the numerator and the denominator to get the rational expression, and then simplify the rational expression where we can. So really, once we find the least common denominator and use it to get rid of our denominators in our fractions, it's just like simplifying a rational expression, which we did in the last section. Okay, so here for A, we have our first complex fraction, we have 4x divided by 9, all divided by, or the fraction 4x divided by 9, over 2x divided by 3. And our two denominators here are 9 and 3. So that's going to make my LCD is going to be, in this case, it's going to be between 9 and 3. The least common denominator would be 9. That's the least common multiple. So I'm going to multiply the top by 9, or think of it like 9 over 1, and the bottom by 9, or 9 over 1. And here, remember, we can cross simplify. So on the top, those 9s will cancel out. And that just leaves me with 4x over 1, or 4x, because we don't need to write it over 1. On the bottom, 3 goes into 9 3 times, so the 3 on the bottom becomes a 1. 2x times 3 will give me 6x. And then it's over 1, which again, we don't need to write. So right now we have 4x over 6x, and we can simplify this. I do know my x's will equal a 1, so we can eliminate those. They equal a 1. And then 4 over 6, I know I can divide it by 2, so it becomes 2/3 is my final answer. And that one was a nice, easy one to kind of get us started. Now, if we look at B, all of my denominators are numbers, so that's nice. And we have 5, 10, and 2. When we look at those for my LCD, my least common multiple would be 10. So I'm going to multiply everything on the top by 10 over 1 and everything on the bottom by 10 over 1. Now here we will have to do a little distributing, so I'm going to kind of write it off to the side. The first one we're going to do is 3/5 times 10 over 1. And remember, we can simplify. So the 5 goes into 10 2 times and becomes a 1 there. So that 3 times 2 will give me a 6. So right now I have this on the bottom. I have 6. Keep our plus sign. Here we simply do 4 times 10. So we get 40 over, on the bottom, 7 over 10 times 10 over 1. My 10s will cancel out, and it gives me 7 over 1, or 7. Keep my minus sign. 1/2 times 10 over 1. 2 goes into 10 5 times. That becomes a 1. 1 times 5 is 5. So now we can do the math here. We can simplify. 6 plus 40 is 46. And 7 minus 5 is 2. 46 divided by 2 is going to give me 23. And that will be our final answer there. Okay, so for C here, we have the expression 6x minus 3 divided by 5x squared, all over, or divided by, the fraction 2x minus 1 over 10x. So my two denominators right now are 5x squared and 10x. So I need to figure out what my common denominator here would be for 5x squared and 10x. Well, I know that between 10 and 5, I'm going to use 10. So my LCD is going to have a 10 in it. And then x and x squared, remember you always want to choose the higher power. So we're going to use 10x squared as our LCD. So I'm going to multiply this top fraction by 10x squared and the bottom one by 10x squared. And I know 5 goes into 10 twice, so that becomes a 2, and the x squareds will cancel. So it's going to leave me with 2 times 6x minus 3 over, and then here my 10s will cancel, and I'll get rid of 1x because I have x squared and x, but I still have 1 left over, so I'll have x times 2x minus 1. We want to distribute here, so 2 times 6x is going to give me 12x minus 6, because 2 times 3 is 6, over 2x squared minus x. And honestly, with this, we are going to take a look at this. Now, we did distribute, and what we need to do now is see if we can do any factoring, because up here I noticed this wasn't totally factored. For 12x and 6, I do know that I can pull out a 6, and when I do that, it's going to leave me with 2x minus 1, which really I multiplied on the bottom. I didn't have to, because if I factor out the x, which is what we had up here originally, I end up with 2x minus 1. And I notice here then I can simplify the expressions 2x minus 1. They cancel out, they equal 1, so I can get rid of those. And my final answer is going to be 6 over x. I think with this problem, it's good to see, like here, once I multiplied that 2, I could still factor this. This isn't the complete factored form. Down here, if you recognize that there's no other factoring we can do here, we could leave it like this instead of multiplying it out. But sometimes we don't always see it, so we go ahead and multiply it out. It's just a little bit more work, but it's not bad. For D, let's see here. We have a denominator of x and a denominator of y. So that means my LCD is going to be, xy. So I'm going to erase that real quick and move it over. So my LCD is xy. So I'm going to multiply everything by xy over 1. And again, when I distribute, 1 times xy will just give me xy plus, and then if I do 3 over x times xy over 1, my x's will cancel because they're a numerator and denominator, but it leaves me with just 3y. So I have xy plus 3y over, now when I do 7 over y times xy over 1, the y's will cancel, but it leaves me with 7x. So we have 7x minus, and then here 2 times xy will give me 2xy. Now I do want to see if I can simplify here. And I do see that like I can factor on the top. I can make it, I can factor out a y. So it would be y times x plus 3 over, and I can factor out an x on the bottom. So it would be 7 minus 2y. But when I factor it, I can't do any simplifying. So really, either of these two would be an acceptable answer. It depends on if they want it in factored form or if they say it's okay to leave it in multiplied form. But both of those are acceptable answers there. All right, so now for E, we need to look at our denominators and figure out our LCD. And I see that I have an A, I have a B, I have a C, and I have an A. So again, your LCD, your least common denominator, has to have all of your unique or different factors represented. So in this case, I feel like my LCD, or I know my LCD needs to have an A, needs to have B, and it needs to have C. And they're all to the first power. So my LCD that I'm going to use is ABC. So I'm going to multiply everything by ABC, or again, think of it like ABC over 1. So, when I do 7A, that's an A, looks a little wonky, times, ABC over 1, my A's will cancel, and it'll leave me with 7BC. We'll keep our plus sign. When I do 5B times ABC over 1, my B's will cancel, and it leaves me with 5AC all over. Now next we do 3 over C times ABC over 1, and my C's will cancel, leaves me with 3AB minus, and then 1 over A times ABC. My A's will cancel, and it leaves me with BC. So now when I look at this answer here, I can, if I needed to, factor out a C on the top and a B on the bottom, but it's not going to give me expressions that I can cancel out. So I'm not factoring out the same thing on the top and the bottom. It won't give me an expression in the parentheses that's the same. So you can leave it in this form unless they ask for it in factored form, but this would be our final answer here. Now for F, my denominators are x, y, x squared, and y. So I have two unique factors. I have x and I have y, and you always want to choose the highest power. So here, remember, we're going to do our LCD. It's going to be x squared, y squared. Because again, you want to choose that highest power. So we're going to multiply everything on the top and the bottom by x squared, y squared. Again, think of it like over 1 if you want to make it into a fraction. So when I do the math, if I do 2 over x times x squared, y squared over 1, here I will get rid of the x on the bottom and one of the x's on the top, but I won't get rid of both. And that's going to leave me with 2xy squared. Then if we do 2 over y, it is 3 over y. So we distribute here and here. So 3 over y times x squared, y squared over 1. My y's, again, I'll get rid of the one on the bottom and 1 on the top. And it's going to leave me with minus 3x squared y. On the bottom, I'm going to do 4 over x squared times x squared, y squared over 1. So my x squareds will cancel, and it leaves me with 4y squared. Keep my plus sign, plus. And then we do 5 over y squared times x squared, y squared over 1. My y squareds will cancel, and that's going to leave me with 5x squared. And again, I could do some factoring here. I could pull out on the top an x and a y. On the bottom, I can't do any factoring. So honestly, even though I could do some factoring, it's not going to help me do any simplification. So we're going to leave it as is. And that would be our final answer. Okay, so for our next one, our least common denominator here, we have x and x squared. So our LCD is going to be x squared. So I'm going to multiply everything again by x squared, or again, think of it like x squared over 1. So if I do x squared over 1 times 1 over x, one of my pairs of x's will cancel, and it leaves me with x, because x times 1 is x. So we have x plus, if I do 3x squared times x squared over 1, my x squareds will cancel, and it leaves me with a 3. 1 times x squared is going to be x squared, minus, and then if we do 9 over x squared times x squared over 1, those x squareds cancel out and leaves me with a 9. So now when I look at this problem, I do notice that I can factor that bottom. It's the difference of perfect squares. So when I factor it, I'm going to keep my x plus 3 on top, but the bottom becomes x minus 3 times x plus 3. And now I have an expression I can cancel. I can cancel out my x plus 3's. They equal a 1. And so remember, because it equals a 1, we can't get rid of our numerator completely. We're going to have 1 over x minus 3 for my final answer there. All right, if we look at h, hopefully you're looking at this one and you're like, oh, I can see here that my common denominator here is going to be x squared because we have x and x squared. So I'm going to multiply everything by x squared, or x squared over 1. And that is going to give me 1 times x squared is x squared. And then if I do 2 over x times x squared over 1, again, we get rid of one of my 2's, and we have minus 2x. Then 1 times x squared is x squared. 4 over x squared times x squared over 1. The x squareds cancel out, and we have minus 4. Now I do recognize here that I can factor the top and the bottom for this one. On the top, I can factor out an x. So it becomes x times x minus 2. And then on the bottom, this is, again, your difference of perfect squares. So x squared minus 4, we can factor and make it x minus 2 times x plus 2. And my x minus 2's are similar expressions, are the same on the top and the bottom, so we can cancel those. And it leaves me with my final answer of x over x plus 2. And that's our final answer. Okay, so the next part of this video, we are going to look at rational equations. And a rational equation is any equation that contains a rational expression. So think you're going to have an equation with some fractions in there with polynomials on the top and the bottom. And just like we would solve an equation with fractions, to solve a rational equation, we're going to find the least common denominator and multiply each term in the equation by the LCD so that we can eliminate the fractions. So we get rid of it and then just solve the remaining equation. Now, one thing you do have to be careful here is once you solve that equation, we do have to check for extraneous solutions. And these are really solutions that would make the denominator 0 in any of our rational expressions. So that is one thing we want to double check because we don't want to turn our denominator into a 0 because it makes it undefined. Okay, so for A here, my two denominators are 3x and 6. So again, between 3 and 6, my least common denominator number-wise would be 6. And we have an x there, so we have to include it. So our LCD is going to be 6x, and we're going to multiply everything here by 6x. Or again, think of it like 6x over 1. So I'm going to do the work here, and then I'll write the equation below the line. So when I do 6x over 1 times 5 over 3x, my 3 will make the 6 into a 2, and the x's cancel out. So we do 2 times 5, and we get 10. 6x times 1 would be plus 6x. And then over here, 7 over 6 times 6x over 1, the 6's cancel, and we do 7 times x. So it equals 7x. And now we have a linear equation, so we just need to solve it. I'm going to subtract 6x from both sides. And that's going to give me 10 equals x. And I'm all done. Now we do want to check our answer. If I plug 10 into my denominator where I have an x, 3 times 10 will not give me 0, so it is a true solution, not an extraneous solution. It works. All right, so for B, we have two denominators. They are both 4x plus 3. So my LCD here is going to be the 4x plus 3, the whole expression. So I'm going to multiply everything by 4x plus 3, or again, think of it like 4x plus 3 over 1. That should be 3. Now the nice thing is here on the left-hand side, those 4x plus 3's cancel out, and it leaves us with just 6. Next, we have to do 2 times 4x plus 3. So we will distribute that. And then for that second fraction, the 4x plus 3 cancel and leave us with just plus 5x. So now let's simplify our equation. We have 6 equals 8x plus 6 plus 5x. And we need to combine like terms. So 8x and 5x will give me 13x plus 6 equals 6. And then we will subtract 6 from both sides. So we end up with 0 equals 13x. Or if we divide by 13, we know that x equals 0. Now remember, 0 is a number. It is an answer. We can use it. We do need to check it in our denominators. And if I plug in 0 up here, 4 times 0 would give me 0, but we have that plus 3. So it is a true solution, and it does work. So it will work with the equation. Okay, now so for C, remember you want your denominators in factored form before you find that LCD. And I notice here the 2x minus 6, I can factor a 2 out of that, and it becomes 2 times x minus 3. So then I notice I have x minus 3 in both fractions, which is good. And I also need that 2. So this becomes our LCD. So we're going to multiply everything here by 2 times x minus 3. And the nice thing is, again, on that left-hand side, the fractions cancel, or the numerator and denominator cancel out, and it leaves us with just 5. And then over here, we need to do 2 times x minus 3. So 2 times 2 is 4 times x minus 3. And then we have our minus sign for right here. And 1 times 2 times x minus 3. The x minus 3's cancel out, and 1 times 2 is 2. So now we need to distribute. And we're going to have 5 is equal to 4 times x is 4x. 4 times negative 3 is negative 12 minus 2. Combine your like terms. So 5 equals 4x minus 14. And here we just need to solve. So I'm going to add 14 to both sides. I get 19 equals 4x. Divide by 4. So x is going to equal 19 fourths, and it's okay to leave it as an improper fraction. And if I go back and I plug in 19 fourths up here, it's not going to give me 0 in either denominator, so it is a true solution. All right, let's look at D. So for D, again, I can factor this x squared minus 4, and it factors to x minus 2. X plus 2, because that's our difference of perfect squares. And that is actually going to give us our LCD because we have the two factors, x minus 2 and x plus 2 in my other denominators. So my LCD is x minus 2, x plus 2. So we have to multiply everything by that. Now, remember, when you multiply your LCD times your denominator, whatever's in common cancels. So for this first one, because this is my LCD, when I multiply it times x minus 2, x plus 2, both expressions are going to cancel and leave me with just 3x. So I'm going to move it down here. We have 3x plus, now on the 5 over x minus 2, when I multiply that times x minus 2, x plus 2, the x minus 2's cancel, but I'm left with 5 times x plus 2. And then on this other side, notice we have x plus 2, so we're going to do 4 over x plus 2 times x minus 2, x plus 2. So the x plus 2's cancel, and it leaves me with 4 times x minus 2. I need to distribute here. So we have 3x plus 5x plus 10 equals 4x minus 8. And then we get 8x plus 10 when I combine like terms equals 4x minus 8. Let's subtract 4x from both sides. So I end up with 4x plus 10 equals negative 8. Subtract 10 from both sides, and we end up with 4x equals negative 18. Divide by 4, and x is going to equal negative 9 halves. And we're going to leave it in that form, fraction form. And again, I know that if I were to go and plug this into any of my 3 denominators at the top, it's not going to give me 0 because it's not a 2 or a negative 2. So it is a good solution. It doesn't make my denominator 0. All right, so now we are looking at E, and I do notice I have that one denominator there that is not factored. So x squared plus 7x plus 12. That would factor to get 12, we can do 4 and 3, which would give me 7 as well. So x plus 4 times x plus 3. And the nice thing is here, that is our common, our other two factors are x plus 4 and x plus 3. So this makes it my LCD right here. So I have to multiply everything by my LCD of x plus 4 times x plus 3. And I'm going to multiply each part, I think, to show you. It's a little hard to write it all out. We're going to do 7 over x plus 4 times x plus 4, x plus 3 over 1. And again, my x plus 4's cancel. So now my equation is going to be 7 times x plus 3. Up here, it's going to be minus. Now, remember, we're going to when we multiply by an LCD, that's exactly the same as our denominator. Everything cancels. So we're left with our expression on the top, 3x minus 1. And because it's a minus, put it in parentheses there. And then for our last fraction, we have negative 2 over x plus 3 times x plus 4 times x plus 3. And my x plus 3's cancel, leaving with negative 2 times x plus 4. So I need to distribute here. And I'm going to have 7x plus 21. I have to distribute that negative to each term in my expression. So negative 3x plus 1. And it's going to equal negative 2x minus 8. Let's combine like terms on the left-hand side. So 7x minus 3x will give me 4x. 21 plus 1 will give me plus 22 equals negative 2x minus 8. And again, here I will add 2x to both sides to combine my x's. So I get 6x plus 22 equals negative 8. Subtract 22 from both sides. So now I have 6x equals negative 30. Divide by 6, and x will be negative 5. And if I check that up at the top, if I plug in negative 5 plus 4 will not give me 0, and negative 5 plus 3 won't give me 0. So this is a valid solution. All right, let me draw a line here. All right, for F, I have a common denominator of x minus 1. So it's nice. I just need to multiply everything by x minus 1. And, when I do 3 over x minus 1 times x minus 1 over 1, those x minus 1's cancel, and it leaves me with just 3 minus, now I do have to do 2 times x minus 1. And then over on the right-hand side, they cancel out and leaves me with a 3. The x minus 1's cancel. So now I have 3 minus, when I distribute, 2x plus 1, or no, plus 2, excuse me, because 2 times 1 is 2, equals 3. 3 plus 2 will give me 5 minus 2x equals 3. I will subtract 5 from both sides. So I end up with negative 2x equals negative 2. Divide by negative 2. So I get x equals 1. Now, when I check this answer, if I plug a 1 in for x, 1 minus 1 gives me a 0. So even though this is an answer to the equation, it doesn't work for our original equation because it turns my denominator into 0. So we would say, in this case, our answer would be no solution. Okay, now we are on G, and my two denominators are 4 and x, so my two different unique factors. So that's going to be my LCD. My LCD is going to be, move that back over, 4x. So my LCD will be 4x. So I'm going to multiply everything by 4x, or again, 4x over 1. So let's do the work here and then write the equation below the line. 4x times x over 4. My 4's cancel, and we'll end up with x times x, or x squared. 4x times 5 over x. My x's cancel, and 4 times 5 is going to be plus 20. And then on the right-hand side, 3 times 4x will equal 12x. Now, this one, because our highest power is 2, it's going to be a quadratic. So I need to set it to 0 and see if I can factor to solve it. So I'm going to subtract 12x from both sides. And I end up with x squared minus 12x plus 20 equals 0. Now it is an easy trinomial, so let's see here. When I factor, I have a minus and a plus in that order, so I'm going to have two minus signs. To get 20, I can do 4 and 5, 1 and 20, or 2 and 10. And I need a negative 12, so I'm going to use 2 and 10. And that means that x minus 2 equals 0 and x minus 10 equals 0. So I'll add 10 to both sides. I get x equals 10. Or if I add 2 to both sides, I get x equals 2. So I have two solutions. And if I plug in 10, because it's just an x down here, because it's 10 and 2, it's not going to turn it into 0 because we're not doing anything to it. So those are two real solutions. So for H, let's see here. We are going to multiply everything by our LCD, and our LCD this time is going to be, we have x and x squared, so we're going to use the higher power, so we have x squared. So I'm going to multiply everything by x squared, or x squared over 1. So when I distribute here, 2 times x squared is 2x squared. And then if I do 1 over x times x squared over 1, remember, one of those x's cancel out on the top, so I have minus x is equal to, and then on the right-hand side, those x squareds cancel out and it equals 3. So again, I have another quadratic. I'm going to set it equal to 0. I'll subtract 3 from both sides. So I have 2x squared minus x minus 3 equals 0. And now we're going to factor. And this is one, it's a hard trinomial, so let's try the box and see what we can do. So I'll have 2x squared, and I'll have 3. And I need to find my middle terms. 2 times 3 is 6. My factors of 6 are 1 and 6, 2 and 3. And I need a negative 1. So I'm going to use the 2 and the 3. My 3 needs to be negative, and my 2 will be positive. So when I factor across for 2x and 3, my greatest common factor is 1. For the 2x squared and the 3x, it's going to be x. When I factor up, 2x squared and 2x is going to give me 2x. 3x and 3 will give me a 3. So it factors to 2x minus 3 times x plus 1 equals 0. And again, set both of those to 0 and solve. So we'll subtract 1. We get x equals negative 1 there. Here we'll add 3. We get 2x equals 3, and then divide by 2. So x equals 3 halves. So we have two solutions. We have 3 halves, and we have negative 1. And because my denominators are x and x squared, when I plug those in, neither of my answers are 0. So both of those will work. Okay, so next for I, again, before we find that least common denominator, we want to make sure we have our denominator factored completely. So that x squared minus 9, difference of perfect squares, I know I can factor it to x minus 3 times x plus 3. And that will become my LCD because I have x plus 3 over here as well. So I'm going to multiply everything by x minus 3, x plus 3, which we know on the left-hand side, when we multiply by our common denominator, and that is our denominator, we're left with just our 36 there. So that's nice. Plus, now here, 1 times x minus 3, x plus 3 will give me my x minus 3. X plus 3 equals, and then on this side, when we multiply by x minus 3, x plus 3, my x plus 3's cancel, and it leaves me with 2x times x minus 3. So I do need to here simplify. I have 36 plus, I know x minus 3, x plus 3, when I factored it, it was originally x squared minus 9, so that's the multiplied form, equals 2x squared minus 6x. We do have a quadratic here, so let's combine. Let's move our x squareds over and add 9 to both sides. I think I'm kind of doing this a little crazy, but so now we have 36 is equal to x squared minus 6x plus 9. And then let's subtract our 36 from both sides. So that gives me x squared minus 6x minus 27 equals 0. And this will factor to 9 and 3 make 27, which also gives me a negative 6. So x minus 9, x plus 3. So when I set it to 0, x here, I would add 9 to both sides, so x is going to equal 9. And here, x plus 3 equals 0. I would subtract 3 from both sides, so x will equal a negative 3. Now, when I go to check my answers, 9 is okay. It works with x minus 3, like 9 minus 3 is not 0, and 9 plus 3 is not 0. But negative 3, if I do negative 3 plus positive 3 right here, it gives me a 0. So that means that would be undefined. So even though I have two solutions here, my only solution is x equals 9 for that equation. All right, let's look at J. We definitely need to factor this expression, the 2x squared minus 5x minus 3. So I'm going to box it over here. 2x squared and a 3. 2 times 3 is 6. I need two different signs. I'm going to use 6 and 1 because I'm going to do a negative 6x and a positive 1 to give me that negative 5. When I factor across, my GCF for 1 and 3 is 1. For 2x squared and 6x, it's going to be 2x. 2x squared and x is going to be x. And then 6x and 3 will be 3. So factored form is 2x plus 1 times x minus 3, which is kind of nice because my two other denominators are x minus 3 and 2x plus 1. So this is going to be my LCD, which means for this first fraction, if I multiply by my LCD and it's the same, we're going to have 2x squared minus 23 plus, here, you should be seeing a pattern here. We have 2 over x minus 3. My x minus 3's cancel. It leaves me with 2 times 2x plus 1. That's what's left. And then on this side, I have the 2x plus 1, but I'm missing the x minus 3. So it's going to be negative 1 times x minus 3 on the top, because that's what's missing. All right, let's distribute. So we're going to end up with x squared minus 23 plus 4x plus 2 equals negative x plus 3. Combine like terms, so we have x squared plus 4x. Negative 23 and 2 will make it minus 21. And then equals negative x plus 3. And then we're going to add x to both sides and subtract a 3. So my final answer here, when we make it equal to 0, is x squared plus 5x minus 24 equals 0. And this will factor to 24. I know 8 and 3 give me 24. It also makes a 5. So we're going to have x plus 8, x minus 3, and x plus 8 equals 0. Subtract 8 from both sides. So we get x equals negative 8. And then x minus 3 equals 0. You would add 3 to both sides. So my answers are negative 8 and 3. But when I check my answers, negative 8 would be fine in the 2x minus 1 and the x minus 3. But if I plug in 3 and do 3 minus 3, I get a 0. So that gives me an undefined answer. So even though 3 is the solution to the equation we solved, it is not a solution to this equation. And my only answer would be that negative 8. Okay, so here we have our last two for this video for part 1, and then we'll start with part 2 shortly. Here I have two expressions. I have x minus 6 and x minus 1. So that is going to be my LCD. I'm going to put them together. So my LCD is going to be, x minus 6 times x minus 1. So when I do x over x minus 6 times x minus 6, x minus 1, my x minus 6 cancels out, and I have x times x minus 1. On the other side, when I do negative 2 over x minus 1 times x minus 6, x minus 1, x minus 1's cancel out, and we get negative 2 times x minus 6. Distribute, we get x squared minus x equals negative 2x plus 12. I do have a quadratic here, so I have to make it equal to 0. So let's add 2x to both sides and subtract 12. So that's going to give me x squared plus x, because negative 1 plus 2 will give me 1, minus 12 equals 0. And when I factor this, it's going to be x 12, I'll use 3 and 4, and 4 needs to be positive. So x plus 4, x minus 3 equals 0. And then again, when I set them to 0, x plus 4 equals 0. So x is going to equal negative 4, because I would subtract 4 from both sides. And x minus 3 equals 0. I would add 3 to both sides, so x is going to equal positive 3. And here, if I plug in 3 or negative 4 to either of those, it still works. In my denominators, I would not get a 0. So they are both true solutions. All right, and my last one here, I have x plus 4 and x. So my LCD is going to be x times x plus 4. I would put the two factors together. So when I multiply everything times my denominators, remember on the left-hand side, the x plus 4's cancel, and it leaves me with 15x is equal to. On the right-hand side, I get rid of my x's, so it leaves me with x minus 4 times x plus 4. Now remember, when I distribute this, I have to FOIL, so I have 15x is equal to x squared plus 4x minus 4x minus 16, or 15x equals x squared, the middle terms cancel, minus 16. It is a quadratic, so we're going to make it equal to 0. I'm going to subtract 15x from both sides. And I'm going to have 0 equals x squared minus 15x minus 16. Let's see, to factor this, it's an easy trinomial. I know I'm going to have x plus and an x minus, because I have two minus signs. To get 16, we could do 1 and 16, 2 and 8, 4 and 4, but I need a 15. So I'm going to have to do a negative 16 and a positive 1. So that means I have x plus 1 equals 0, or x will equal a negative 1, because I would subtract 1 from both sides. And x minus 16 equals 0, so x is going to equal 16, because I would add 16 to both sides. And when I look at my problem, if negative 1 plus 4 will give me a number other than 0. 16 plus 4 will give me a number other than 0. And if I plug in my numbers there, I'm okay. So my two answers are x equals negative 1 and 16. And that is it for part 1 of Module 4.